That's us. Get in touch. Why are we here? So this is sort of a case study and sort of like navigational waypoints for somebody who's very familiar with Drupal 7 and trying to navigate Drupal 8. It's focused around my experience of updating a Salesforce module from Drupal 7 to Drupal 8 over the course of many years. So we'll hit as many of these points as we can, and I'll talk about sort of the Drupal 7 to Drupal 8 equivalents for the various APIs that Salesforce module uses, and trade-offs along the way. So just real quick, the Salesforce module is actually a Salesforce project is a set of modules that synchronize data back and forth between Drupal and Salesforce. So there's a sort of mapping layer where we take Drupal entities and Drupal fields and map those onto Salesforce tables and Salesforce fields. There's a pull and a push. It's talking about pulling data from Salesforce into Drupal, pushing data from Drupal into Salesforce. And then there's a underlying all that to make it all work is this REST API client. And you can see on here the various APIs that come into play in each of those contexts. The entity API. We had node load, we had user load, we had entity load single in Drupal 7, and now we have entity type manager and storage manager, storage service that do the loading for us. So where we had node load before, we now have Drupal service entity type manager get storage node load, or you can also call the entity load method statically, which is a pass through to the same thing. So this is why is this better? This is more extensible. This gives us the ability to plug in our own handlers. If you want to store nodes in a MongoDB, if you can figure out how to do that, if you want to store them in Redis instead of the database, I don't know why you would want to do that, but you can. It's extensible. You can plug in your own entity type manager service. Everything here is pluggable, whereas before, node load offered very few opportunities. There was a hook node load, hook entity load, and that's it. That's all you got. But now we have lots of different places to hook in our own logic and do whatever we need to, which in turn makes this more dependable and definitely more testable. So there are unit tests for everything in Drupal core. I don't know about everything, but for a lot of things in Drupal core, and there are in Salesforce as well. So dependency injection is a big thing. We'll talk about that in a little bit. But by enabling pluggability, we can isolate one aspect of our code to test just that aspect and plug in sort of dummy services and test just that one thing. So how does this work in Salesforce module? We have a couple entities in the Salesforce mapping module. We have the Salesforce mapping, which is the sort of config that defines this field in Drupal goes to this field in Salesforce. And then we have the mapped object, which is basically a join table. So we link an entity in Drupal, an entity ID, an entity type in Drupal to a Salesforce ID. So the Salesforce mapping is a config entity type, and the Salesforce mapped object is a content entity type. And this distinction is a welcome sort of red line that we did not have in Drupal 7 as much, to distinguish something that's config, something that makes sense in lots of different contexts, different environments, dev, test, production, in your branches, versus something that's content that may be totally different, have different identifiers, and you want to be completely separate in different environments. That's one distinction. So to define my entity, I'm using this annotation where I'm specifying a custom storage handler here. I have a storage schema, and all of these are extending Drupal core classes to, for example, my storage handler here provides some convenience methods. So I can load a mapped object given a Drupal object, load by entity. If I have the entity type and entity ID, I can load by those. So those are some things you might do with a storage object. You might have, you can. There was a talk at DrupalCon that demonstrated loading an entity from an API. So replace, basically, there was no storage on the Drupal side. The storage was an identifier that called an API and displayed that. It's not exactly what we're doing here for a number of reasons, but you can if you want. Excuse me. Cool things about the annotations. This is your views integration. Views data and view builder. All I have to do is specify those two lines, and my content entity is now available to views. I literally changed nothing. These are Drupal core classes, and I can make a view now of this data if I want to. So there's a lot in here. I'm not going to go into too much depth about each API, but the entity API, again, very powerful. What happened to my? There we go. So that's entity storage. Let me just look at the config object real quick too. So config object is very similar, except my schema is defined in a YAML instead of in my content entity. The big method here is base field definitions. So in base field definitions for my content entity is where I'm actually adding the fields for this this content type. And these fields are, again, this is the join object between Drupal and Salesforce. So I have a dynamic entity reference to a Drupal entity. I have an entity reference to the mapping that spawned this join record. And I have a string reference to the Salesforce ID that does the sort of connection to Salesforce. And then some sort of convenience things like a link to the record in Salesforce, metadata, created, changed, keeping track of the last sort of status, what happened on the last transaction between Drupal and Salesforce. For a config entity, I don't have a base field definitions in here because the schema is defined in my YAML for this config object, and this means so I'm defining all those fields that will define a Salesforce mapping entity instance, and then when I export one, which I can show you in the example module, each of those config items will be filled in. So this we're looking at right now is an instance of a config entity. This is a Salesforce example contact, and I can do a lot of the things that I would do with features in Drupal 7 with this config entity. So I can push this up to another environment and sort of deploy it there. I can version control it, and it's so much easier than working with one of those monolithic features files that's unreadable and unmaintainable, and you can't edit by hand. So I think that's all I wanted to say about the Entity API. Next up, we have the plugin API, which is this huge kind of idea, and the plugin API is like an API for defining plugins. So it's like an API for defining APIs, which doesn't really make sense until you look at a concrete example. But what I was able to do with the Salesforce module, and what we're able to do now in Drupal 8 is replace all kinds of the old way of doing things with something that is, again, more extensible, more dependable, more testable. So before we had this API info hooks. We have module invoke all. We have API data hook. We have API callback function. All that now is done with plugins. So what do those look like? We have, for Salesforce, we have the example that I will show is the plugins that build the actual mapping. And we'll see if I can get a live demo of that. So just so you have some context, I just want to demonstrate what this mapping form looks like. So on your left, you have your Drupal properties, and on your right you have Salesforce fields. So this is a mapping between, I think, Drupal user and a Salesforce idea, which doesn't make any sense. Let's make it to a contact. But each of these fields is defined by a plugin, and each field type is a plugin type. So if another module wants to create a new plugin type, there's an API for that inside of the Salesforce module. And in that module, all they have to do is basically to declare the right file hierarchy, and voila, that field type will appear. So in Salesforce mapping, under the source directory, under the plugin directory, and capitalization matters, the directory structure matters here, are all the plugins that this module is implementing. So we're implementing a derivative plugin, a field plugin, a menu plugin, a validation plugin, and a Salesforce mapping field plugin. This is the API that Salesforce module defines and implements, and all the other ones are either from contrib or from core APIs that we're implementing. So I'm going to take a look at the one that's implemented in here and sort of gloss over the other ones. So my mapping field plugin manager is pretty simple, but what it does is defines sort of the namespace for my plugin system, which is this line right here, and that's basically it. I'm calling a cache backend to give it a specific cache key there, and that's sort of arbitrary. But this is the key statement here. It's telling the plugin API where to look for those plugins. It's going to look in the plugin directory, in a Salesforce mapping field directory, and anything it finds in that directory, if it is declared correctly, it will be exposed as a plugin. So by declared correctly, I mean it has this annotation, and it's in this directory. That's it. It doesn't have to extend any particular class, although a typical pattern is to define a base class where the common methods between your classes are defined, and then your plugin instance will extend that class, but you don't have to do it that way. In this case, we do have this base class that does some of the sort of common things. It's got our dependency injection constructors here, and a couple, but not all, of the methods required by the interface. So we have the plugin interface, a base class for that, and then the plugin instances that all inherit from the base class. That's a very typical pattern in Drupal. So what does this plugin actually do? In this example, each of the plugins are going to have a slightly different configuration form. So, for my properties plugin, I'm just exposing a list of all the properties on the Drupal entity for a constant, which means like basically just always send this value to Salesforce. You can see the direction it can only go from Drupal to Salesforce. This form is defined in my constant build configuration form method. So the Drupal field value is what it expects to find, and that's a text field. Whereas for properties, the Drupal field value is a select action. So that's a relatively simple, well, not necessarily simple, but quick example of how you might use the plugin API. Just real quick, this is another example of a plugin API that implements the derivative plugin, and what this does is add a Salesforce tab to any entity which has a Salesforce mapping. So if I create a mapping between user and contact, now whenever I visit a user on my Drupal side, there'll be a Salesforce tab, and I can click on that tab and see, let's see, don't make a liar out of me. And I can see a Salesforce tab here, and this plugin then hands that off to routes that I have defined elsewhere. But this plugin itself adds this Salesforce tab, which took a long time to figure out how to do that, honestly. And most of the documentation in Drupal 8 is good, but for me, I'm a very sort of tactile learner, so most of the learning that I did was looking at Views module, looking at Devel module, looking at these sort of like big modules that implement, that in many cases were the cause of creating this API in Drupal core in the first place. So I was looking at those modules to get examples on, how do I use this API? How do I do this thing? So like I knew Views does a lot with tabs. I knew Devel added a tab. I saw how Devel did it, and then did the same thing for Salesforce.
You're not the only one.
Yeah. I mean, it's hard to navigate, and just yesterday I was looking at a Drupal 7 method and found one of my Drupal 7 method in the Drupal 7 function on Drupal.org API, and found one of my comments directing myself to one of the Drupal 8 versions of that. Anyway, so that's plugin API. The Queue API. I don't think it's a very popular API, but for Salesforce, we rely on it very heavily to move the data asynchronously between Drupal and Salesforce. The network connection, we don't necessarily want the user to wait on that. We don't want that to be a blocking operation. So we use the Queue API extensively in Drupal 7 and now also in Drupal 8. And the Queue API is an example of a plugin API. So Drupal core defines a plugin API for a queue worker, and we implement that in Salesforce Push and Salesforce Pull. So I'm going to look at Salesforce Pull first of all, because it's a little simpler, and then I will look at Salesforce Push as well. So in Salesforce Pull, there are a couple different things. We have a queue handler service, and we have a cron hook that instantiates that service and does the queue handling. What does that queue handler actually do? In this case, for Salesforce Pull, what it does is gets updated records from Salesforce, sticks them in a queue, and then quits, essentially. So you have this queue handler service running cron. It puts things in a queue. How do they get processed? Because in our queue handler, there's nothing to actually process those items. It's literally just populating a table, which is a DatabaseQueue. That's where the queue worker plugin comes in. So in Drupal core during cron, any module which has defined a queue worker plugin, that queue worker plugin gets instantiated and processed during cron. And you can set various. Well, I think all you have control over is this cron time. I think this is actually the only annotation besides ID and title.
I think that's the max time for the queue to run.
Is that what it is?
I believe so.
Okay. I'm not. Okay. I think it runs every time. Every cron. It's not like Elysian cron is now in core. I think you're right. So this queue worker will run for
time.
Max for 3 minutes. So that this is the class that actually processes the queue. Even though this doesn't do anything, it's all pull base. So pull base, basically my cron pull class inherits all these things from pull base, and the pull base does the processing of those items in the queue by being called from Drupal core during cron runs. And the things that I have implemented here are process item. I believe this is the only, or this is the main function. Process item, and everything else is protected. So your queue worker base gives you nothing, but it extends this queue worker interface, which requires a process item. So even though we're not getting anything from extending the queue worker base, we're implementing the queue worker interface by extending it.
You're required to implement the process item.
Which in turn means that we're required to implement process item. And process item is what gets called from Drupal core to read a row from the database and process it. And in our case, that means call Salesforce, not call Salesforce, because the Salesforce data is in the queue. So basically, all we're doing is marshaling that data, turning it into a Drupal entity, and saving it or updating an existing entity. So that's a simpler example of the Queue API. For Salesforce Push, our needs are a little bit different because what we want to do for Salesforce Push is actually to optimize the API usage. And what Salesforce allows us to do is group n number of records together and push them all in one API call. So up to 200 records we can push in one API call. But that means we need our own database queue because the Drupal core queue serializes all its data into one column. So we can't, and when we have one record, it's all serialized, which means we can't load up, for example, all of the records of a certain entity type or of a certain Salesforce class that we need to group together into one transaction. We can't, let's say, you can't push a contact into Salesforce without an account, so you have to know what are my accounts that need to be pushed and push those first. So we need to implement our own queue, and that's what I've done with the push queue class that extends the database queue. And just some hand waving here. The essential method here is our schema definition. In the core DatabaseQueue class, the schema definition is like the old school way. Is the way that we used to do it in Drupal 7 is how they've defined the DatabaseQueue database schema here. And this class gets called to create the database table if it doesn't exist. But so if we override that method, we don't have to override the method that actually creates a table. This ensure table exists. We just have to override the schema. And this is the great thing about inheritance and object-oriented programming, and Drupal 8 has that in spades. So you can see what I've added here are just some sort of metadata: the entity ID, the Drupal entity ID, the name of the Salesforce mapping, a unique key. That's for the database entry. The operation. So this is important because I want my deletes to be processed separately from my creates, for example. And then some way to track the failures, because I don't necessarily want to give up on the first try, but I don't want that data to be lost. So there's a retry mechanism built into this queue. And then I also have a queue worker, the push queue processor. No, this is not a queue worker. Sorry. It works like a queue worker. It doesn't implement the queue worker interface. It works a little differently. But I have a process item method, just like I did in the queue worker interface. It just doesn't happen to implement that interface because that interface doesn't give us anything. So that's the database API in a nutshell. Let me keep going. Events API. So Events API replaced for Salesforce module, it replaced basically all of our module invoke all and all of our hook alters. So the Events API gives a similar power to those concepts, but does it in an object-oriented way. And so what does that look like? The way that we have implemented it is there's this sort of constant class. This probably could be a final. But each of the members of this class are constants which define what we used to refer to as a hook are now events. So there's a push allowed event. And there's pointers to what those hooks were in Drupal 7 and pointers of how they work now. So as the Drupal queue API is processing items in the push queue, are those items allowed to be pushed? Any module can subscribe to this push allowed event and say yes or no. Yes, it can be pushed. No, it can't be pushed. Or I'm agnostic. I don't care whether you push it or not. So let me take a more concrete example. The important thing about events is you need a couple different things to use them. You can't just write a function anymore with a particular name and poof, all of a sudden you're subscribed to an event or implemented a hook. You need a services YAML that exposes your event subscriber, like so. And then you need to define that event subscriber, like so. There's an event subscriber interface, and the required method is get subscribed events, which returns an array of the events to which you're subscribed. All of those events should have a unique namespace. I don't know what happens if it's not unique, but bad things, so don't do that. And the convention is module dot, some identifier, because module's namespace is already unique. So in this case, for the example subscriber, I'm subscribing to 1, 2, 3, 4, 5, 6 methods here, and they refer to subscribing to 6 events as the array keys, and the array values are methods within this subscriber. So for push allowed, I have a push allowed method. And if I go back to the definition for push allowed, I can see that the event listener method receives a push allowed event instance. So that's my type hint here on the push allowed method. And then my logic goes inside there. That's an event subscriber in its essence. So you notice it's not by reference because all objects are passed by reference. So whatever I do on this event is going to bubble up to the caller, whoever invoked that event. What that caller decides to do with it, that's up to the implementer of a particular event. But in this case, what the push allowed event defines is this disallow push method. So I lied earlier. You can't allow or be agnostic. You can only disallow. If any event subscriber disallows push, then any particular record, any particular entity that's getting pushed is not going to get pushed during that round of processing. So, for example, you have a user somehow on your Drupal site that was created without an email address. You don't want that user to end up in Salesforce as a contact without an email address. You could disallow the push here. So that's... Oh, let me show an example of an alter as well. So what was before hook Salesforce Pull select query alter is now pull query event. And that looks like it receives a Salesforce query event. And that event itself, instead of having 20 arguments or whatever to my subscriber, I've just defined one event, and then I can, if that event changes over time, I can add methods to expose additional properties on that event. So in this case, there's a mapping and a query that are exposed via this event. So when my subscriber gets that event or receives an event, we can take some action based on what the mapping is. So for example, if I'm pulling a contact, maybe I also want to pull an attachment whose name is example.jpg. I don't know, maybe you have your profile pictures in Salesforce for some reason, and you want to pull those down into Drupal. Or I can pull, instead of mapping the entire account record connected to this contact, I'm going to add the account name just to the contact query and then do something with it. So you can see what I've done here is query is event get query, and again, it's an object, so it's passed by reference. Whatever fields I add here, conditions, limits, those bubble up to the caller. So it's an alter because it's an object. And that's great. It makes everything simpler. I don't have to worry about, I still could worry about collisions with other modules. They could undo all the things that I've done, but that's a exercise left to the reader, let's say. So that's Events API. In core, one other example I do want to show is what we've done in Salesforce. The Salesforce module tends to produce a lot of log entries. So what we did is consolidated the logging into the Salesforce Logger module. So within the various Salesforce modules, instead of calling Watchdog, or instead of calling Drupal Logger, what we do is we fire a Salesforce Salesforce Logger event. What are we calling them? Salesforce exception event, or it's Salesforce notice, Salesforce error, Salesforce warning event. And then this logger just logs us to the database. So if we're finding and there's some settings here, right? Like I could say only log errors or only log warnings, similar to how Watchdog or Drupal core kind of work. Or if I'm finding my logs are filling up, I could just disable this module. If I want to send an email instead of writing to Watchdog, just disable this module and create my own event subscriber that does that. By consolidating those concerns into this single event type, I don't have to worry about subscribing to a Watchdog event and then parsing none of that's relevant. I just subscribe to these events and do something with them. And then my exception event interface has more information than a Watchdog string might have. So I can get the exception. I can do stack tracing. I can extend this even further if I want.
Do you have a jump back one slide? Okay. Thank you. I just
Sure, and I can post these online if people want to see them. Okay, so this is not an API per se, but I did want to demonstrate this as an example of sort of the power of extensibility. So the Salesforce REST API client in Drupal 8 replaces the old one from Drupal 7. The old one in Drupal 7 wasn't a class, so that was a positive. The methods inside were atomized, which is also a positive. Each of the different resources on the Salesforce REST endpoint had their own method. That was great. But the PHP file contained 3 different classes. There was a Salesforce API client, there was a Salesforce exception, and some other class in that one file. The file name didn't match the class name. The return values were not reliable. So in Drupal 8, we have, we're adhering to PSR4. But what we also done which is cool, is normalize the return values for a lot of those methods. So before, we would just return a big array, or sometimes it would be a string, or sometimes it would be a JSON string, or sometimes it would be a Boolean, or sometimes it would be null. Now, what we have for a lot of these is, well, not for a lot, but for a couple, we have a REST response, which is a class. It has methods, and you can, do things that you do with classes. It's got a getter, so you can, look at the properties of that response as though it were a first-class object, and that response gets instantiated from a JSON string. Excuse me. From a JSON string that we get back from the REST API. So we have reliable return values for the describe call, which is similar to MySQL describe, just tells us metadata about a particular table. For the resources call, which tells us all our various REST resources. And what does that look like? Right, so in my let me find a better example here. Right, okay, so in my API call method, I'm accepting a path and some parameters for that path. When I actually call the API HTTP request, it actually invokes guzzle request and returns a raw JSON string. And I just pass that through to REST response here, and I may get an exception if I can't parse the response, if there's some kind of error, and that will sort of either be handled or not. But at the end of the day, the response is returned, unless I've explicitly said not to return it, and I return the raw data, and my caller knows how to deal with that response a little better than as though if it were just a string. So each of those methods are still atomized. They just have a little better way to deal with the results. In the case of a query, I can then pass that through to another wrapper. If I know the response is going to have a more particular format than just the REST response that we defined sort of generically. That's one thing I want to call out. The other thing I want to call out was, right, type pending, we sort of covered that already. The other thing I want to call out is, so this REST client is exposed as a service, which doesn't do anything in particular. Here's our dependency injection. So the way that works is in my service class constructor, what I'm doing is calling in other services as dependencies of this service, and then when Drupal core instantiates this service, it passes whatever those services are into this constructor, and I can use them. So in this case, a various number of other services that this service relies on. What I can do, since I've declared it as a service, is I can replace it with another service. And in fact, that's what we've done in Salesforce Encrypt module. So Salesforce Encrypt, you can see, does not have a services YAML. I don't want to look at routing. But what we've done with Salesforce Encrypt is, how do we do it? Oh, no, that's not it either. Okay, yeah. So this is kind of an awkward API, but by creating a Salesforce Encrypt service provider that extends a service provider base and giving it an alter method, what I'm able to do is replace the Salesforce client declared by the Salesforce core module with my own client. So in Salesforce Encrypt, we have our own REST client class, and the Salesforce Encrypt service provider uses that class instead of, like I said, the one defined in Salesforce by the Salesforce .module service. So in this case, what we're doing with that service is, rather than store the consumer key and the consumer secret and the Salesforce identity just directly in the database, we're encrypting those before we stuff them in the database. And we can do that relatively simply. There's a couple hundred lines here. Most of it's sort of just wrappers, though. So we have enable encryption, disabled encryption, set encryption. Most of this is like dealing with the encryption API to manage to get the profile. The encryption API, you have to define an encryption profile where you provide the key, and so this is loading up that profile so that we can encrypt and decrypt things. So then get decrypted and set encrypted are sort of the worker methods here that actually will read a value from the database, decrypt it, and return it to the caller. You'll notice we don't have to declare any of those things which are already declared in the sort of core REST client because we inherited them. We just extend the core REST client and voila. So, right, so this is the core REST client, and we're inheriting that with a different namespace or with a different sort of localized class name so that we don't have conflicts. So that's kind of the services API. I think that's all I want to say about that. So key takeaways. There's a low barrier to implementing new APIs, and I mean that sounds counterintuitive, I guess, because we've walked through like a lot of code. There's a lot of sort of like framework code. But what I mean to say is, you can extend a class rather than like if you wanted to replace, the node view method or the node view function in Drupal 7, you basically have to rewrite that whole function in your own class, even just to change one line. So things are more compartmentalized, isolated now. You can extend a class and then just override the one method that you want to override. That's object-oriented programming. Finally, we had objects in Drupal 7, but they were all std class, so they didn't actually have any methods. The plugin API and annotations reduce overhead, because you're writing a comment basically to define these very complex interactions between systems. And a lot of things we get for free. So, for example, the views annotation, right? We just define a views annotation, and poof, we get views for free. We define the list builder. We get a list for free. Forms are still a pain, but a lot of things we get for, like the config management we get for free. And, object-oriented programming, if you're coming from a solely Drupal background, it's a big learning curve. If you're coming from any other object-oriented programming language, Drupal 8 is finally going to make sense. Where Drupal 7 was I have to relearn programming now because Drupal 7 invents all these new ways of doing things and works on conventions rather than standards. So, Drupal 8 makes sense. There's still Drupalisms and there's still the Drupal way, but there's also finally we're using object-oriented programming, so that you can take advantage of these things, and if you know how to navigate that kind of system, it will be a lot easier. The one thing I would say is Drupal is still very unopinionated, meaning there's 20 different ways you could do a task. So rather than fight against Drupal, take some time before you start doing something and figure out what is the Drupal way to do this, because even if it takes you more time to learn up front, you're going to save time down the road because you're going to be doing it in a way that's supported by your framework. I mean, this is generally true of all frameworks, right? You can probably do something by, putting SQL queries in your template file, but don't do it that way. So that kind of bleeds into early architecture decisions are important. Changing the name of a class is a pain. Changing the name of a modules is still a pain. If you're doing tests early or doing test-driven development, that's gonna save you time. And look for patterns in core, right? I inherited a project where it was the previous developer, sort of understood what they were doing, but not they had created a class called entity storage, such and such entity storage, but it didn't extend a storage class. It wasn't implemented as a annotation storage for the entity it was supposed to be handling, so it didn't actually. So just take some time and learn how things are done in Drupal core. If you're trying to build something, look for a pattern first. Core services.php is going to be invaluable for anybody working with services because there's no actual connection. The only place that connects a service with its tag is the service's YAML file. So, for example, in my Salesforce services YAML, I have the Salesforce.client, but then, and it links me to this REST client, which is great. But in the REST client, if I'm in the REST client, I have no way to know what is the name of the service for this client interface, the HTTP client interface, or the config factory interface. I have no way to get that tag from the other unless the developer happened to drop it into a comment. So, but core services YAML is sort of that map. So all the services defined in core, you can, when I'm developing, I keep a copy of this open so that I can find those service names and match them to their classes very quickly. And PHP Storm is great. I highly recommend it. It will let you navigate these things much more easily. If you're not using it already, you should. In Drupal 7, there were more limitations because the conventions of the hooks or whatever. Like it was hard to navigate with PHP Storm. It was hard for me at least. Most of that has gone away now in Drupal 8. There's an examples module for Drupal 8 that has lots of implementations of these APIs. If you don't want to dig through, views or whatever, if you need sort of more guidance on looking for those. I guess that's it. So yeah, we got a few minutes for questions. I know that was a lot of information.
I have a question.
Yeah.
So, have you used Drupal 7's Salesforce push pull?
I have maintained it. Yeah.
You maintained it, but you never really used it?
No, I mean, we use it on all our Drupal 7 sites.
Right? Of course, you had to.
Mm-hmm.
One thing when I was first setting it up, whenever I do push and pull, it seems like I had to write a special trigger in Salesforce so that basically what I have is a list of requirements that are like incomplete, and they get marked as complete. Mm-hmm. And sometimes because the push and pulls were on different times, running on different cron times, it would overwrite the complete status with the incomplete. So we had to make two classes. We made one that was all the fields, and then we had another one called Salesforce, and then all the fields. Mm-hmm. So then that way, it only updated one-to-one to that one class and not bidirectional, because the bidirectional seemed to be overwriting.
Right. So what I've done in that case is implement a push success handler. So if I'm pushing data from Drupal, I implement a push success handler to immediately pull that record again to get any of those fields that were changed by a trigger or by whatever. That's the best solution that I've come up with.
Yeah. All right. So it's just like a rough thing.
Yeah. I mean, generally, I also try to avoid the bidirectional.
Yeah, that's
as much as possible.
We wound up saying is bidirectional.
Like do a mapping for push, do a mapping for pull, and hopefully also have them on different records if you can.
Right. Exactly. Well, thank you very much. Very informative.
Sure. Yeah. Anybody else?
Regarding the plugins, as you said, we can, as long as we follow that naming convention and other things, we can reuse the whole plugin. Right? Is there a chance of any kind of conflict with the function names or something like that?
There shouldn't be, because they're namespaced. So, for example, if I had a so I'll just use this Salesforce properties example. If I had a different module, let's say MyModule, whatever, that defined a plugin called properties, it could be identical to this, and it should be fine because it will have a different namespace, right? It will be MyModule. So as far as PHP is concerned, as far as the plugin system is concerned, it's a totally different module. If you have, now that I've said that though, I see that there is an ID. If you have the same ID, you might run into a conflict there. I think this ID has to be unique. I don't know what would happen if one would overwrite the other, or if the whole plugin system would just blow up and refuse to use it. But again, the handling. If you did want to replace an existing plugin, there's a plugin alter API that you could use for that. As with any annotation, basically there's I don't know offhand. I haven't had to do that, but for most annotations, you can hook into that annotation system and change the source before it gets sort of instantiated into the plugin manager. So the process looks something like, Drupal bootstraps, Drupal instantiates the plugin system, Drupal reads through all the plugin annotations, and at that point calls some event or an alter hook or whatever it's going to do before it actually then instantiates all those plugins. I don't know if that answers your
Yeah.
question.
And being a maintainer of a big module, like how you kind of like take a check on the performance, or like how really my module is kind of impacting the whole performance?
Yeah, okay, that's a good question. How do you sort of performance profile?
Yeah.
I mean, that's a bigger question than just this module for sure. But I mean, I haven't had the need to do that specifically with Salesforce module because like we know that the network activity with Salesforce is going to be a huge bottleneck. And so we try to keep that asynchronous, and if it's not, then we know it's going to be a huge performance issue, at least as far as the user is concerned. But I mean, generally we've used tools like New Relic to identify long-running processes or memory hogs, and it's usually views or the menu system that are the biggest hogs. I mean, although PHP 7 and Drupal 8 are so much faster than Drupal 7 and PHP 5. So,
Thank you.
sure. Anybody else? Cool. Thanks for coming.